In this video, we're going to take a look at solving a type of equation that we haven't solved yet in this class. And we're going to use a strategy that we haven't used too often. So I want to prepare you for the fact that inverse operations are not actually going to take care of everything for us. So what are we going to do? We're going to solve quadratic equations using the zero product principle. And quadratic means that it's going to have an x squared in it somewhere, like some of the equations we've solved recently. But we're going to have to use the zero product principle. In the last video that you looked at, we solved quadratics, but we were able to rely on inverse operations. And this video is going to show instances where you can't do that. So we don't know yet why, but this is an equation that you can't solve using inverse operations. We're ultimately going to have to use the zero product principle. Very quickly, I'm going to introduce you to a very common error because you've spent months and months and possibly years using inverse operations. So it's pretty classic to see something like this. Add 6 to both sides, 6x, okay, good balanced move. I don't see why not. Okay, there you go. I want to get x by itself. I'm pretty close to having x by itself on the right-hand side. Let's divide both sides by 6. Fantastic. My right side becomes x. That's what I wanted. And x equals 2/3 x squared. Now, because we did balanced moves, inverse operations, we have a true equation. Left side equals the right side. But x isn't known yet. If you look at it, it's telling us that x on the right side is equal to some mystery. When you solve an equation, you want to have x as a number. Okay, so let's scrap that. Let's take a look at this. There's unfortunately a second common error you might run into. Starting off the same way, maybe you say, okay, I'm not going down this path again. I'm not going to divide both sides by 6. Let me look at the x on the left-hand side and see if I can't isolate it over there. So that would take, let's see, dividing by 4 on both sides. Okay, good. Square root, you're not going to trick me. We need a plus or minus. That's because that fundamental theorem of algebra, we get 2 answers. Okay, so the left-hand side becomes x. The right-hand side is both answers, positive or negative, square root of 3x over 2. Well, x is still unknown because x equals nothing, not a number, not a constant. It's some mystery. So once again, this is a true statement that's equivalent to the original, but it's not an answer to an equation. So let's go back to this thing and say, all right, when we see x squareds and x's in the same equation, and we're unable to use inverse operations, we're going to use the zero product principle. So you've only recently been introduced to it. I'll slowly talk about what the zero product principle is. The idea is that you can factor as a step for solving. And if you get factored equals 0, then you've written a multiplication problem where you say, something times something equals 0, and there are very few ways that can happen. If something times something equals 0, then one of those somethings was 0. So let's take a look. The left-hand side is our goal, our target. We're going to factor that thing because the right-hand side is already 0. And if we get factored equals 0, we have a logical approach. Not inverse operations, we have a logical approach. So let's see, 2 terms on the left-hand side. If we're going to factor it, our factoring ideas always start with GCF. Let's take a look at those. I see 2's and x's in the first term, 2 and x. Yeah, so I have a greatest common factor of 2x. I'll take out a 2x from each term. I'll write one set of parentheses, like any good greatest common factor factoring it does. And I'm left with those 2 factors. Now from here, this is the new step. Because if you're keeping track of solving equations and you walk in and you see that, that expression cold, you might be tempted to distribute. But we just undistributed. We have to think of the zero product principle, which says, when I know that 2x times 2x minus 3 equals 0, well, then either 2x is 0 or 2x minus 3 is 0. I'm pausing because that's the place where you have to use logic to solve an equation and think about it rather than inverse operations. So when blank times blank equals 0, set each of those parts, each of those factors equals 0. And good news, we just took this quadratic equation and we instead now replaced it with 2 linear equations that when you combine their answers are equivalent to the answers to the original. So I could solve the left-hand equation very easily, dividing by 2. I find out that x equals 0 is a solution, one of the 2 solutions. And then adding 3 and dividing by 2 over here, I find that x equals 3/2 is another one of the solutions. So apparently this first equation up here, as suggested by the fundamental theorem of algebra, is going to have 2 answers to it. And we just found out that those are 0 and 3/2. And look how much better that solution is than what we had on those earlier slides where x was still unknown. So it takes some time to get used to it. So you'll get at least one more example here. But the idea is when you see an equation and you notice x squareds, you can certainly look at something as, well, let me see if I can unravel this, if I can use inverse operations. But when you see x squared and x, getting this x alone and getting this x alone by inverse operations are going to call for two different things, and the other x will appear on the other side of the equation. So this is the kind of setup where you have to use the zero product principle. Now, it looks a lot different in the last one because there's 3 terms on the left-hand side, but still we know how to factor 3 terms. First thing we look at is for GCF, and I see some commonality in the first 2 terms, but not the third. Okay, that's out. Is it a perfect square trinomial? Well, the first term's not a perfect square, the last term's not a perfect square. So I was hoping to maybe get away with that, but that didn't work either. So we're stuck doing that factor pairs. And remember, when you have a number in front of x squared, we did a lot of different work on this, but ultimately boils down, most efficient is factor pairs of -24 that add to a -2, and those numbers are -6 and 4. And you can use that information a couple different ways. I use it as efficiently as possible to come up with a factored expression, and now I have exactly where we wanted to be. Factored equals 0. I took that quadratic, and I wrote it as 2 linears multiplied together. And one of those linears has to equal 0. Because how else are you going to have something times something equals 0? So 2x plus 1 could be 0, which would lead to, or maybe 4x minus 3 could equal 0. Those are the only 2 options. And solving the equation on the left, we've done that a million times. Solving the equation on the right, we've done that a million times. We have 2 answers to this quadratic equation: x equals -1/2 or x equals 3/4. So you get a focused set of problems today where you do need to do a lot of factoring and solving each linear equation. So make sure you're getting 2 answers out of these things. And if you're having a hard time with factoring, you should definitely go back and take a look at some of those other videos or the other work you've done. Thanks.